Hello there, my name's Marcus and we're here in the BMW wind tunnel. In today's video we're going to tell you something about the aerodynamics development of the new BMW M3 and M4. Aerodynamics is a very important and interesting subject. It's important for many different characteristics of the vehicle. Driving performance, driving dynamics, engine cooling and fuel consumption are all influenced by aerodynamics. At the beginning of the project, we start with numerical simulations on computers to test and evaluate the new design. Then we move on to wind tunnel testing, where we initially test clay models and then the prototype vehicles. Finally, we test the final production car on the racetrack. Here you can see a complete vehicle simulation of the M3 with which we've ensured that the requirements for cooling air for the engine and brakes are fulfilled. Our aim was to maximize the airflow and achieve the most evenly distributed inflow for the radiator. For the M3 and M4 we calculated many different versions of the front skirt and decorative grille and optimized a few not always visible details to achieve maximum airflow for this front design. With a simulated flow field and despite the lack of space, we arranged the airflow so that the cooling air reaches the radiator uniformly and with as little loss as possible, and that it hits exactly the right spot through the wheelhouse for the brakes to be optimally cooled. My name is Alex and I am the aerodynamicist responsible for the M3 and M4. I'm standing in the wind tunnel on the rolling road system. We've put down a mat to protect the metal belt, and behind us we can see the clay model of the new M4. In the early phase of vehicle development, beginning with the first design sketches, we work very closely with the designers. We then build up a full-scale clay model for testing, as you can see here. Together with the designers, we try to optimize the vehicle geometry to the last millimeter to get the best aerodynamic performance.
Strömungsoptimal umzusetzen. Hierbei probieren wir natürlich die Designvorgaben.
Of course, it is a challenge to optimally combine the design characteristics and aerodynamic requirements. That may mean in certain areas of the vehicle that we want to modify the geometry. Take the area of the headlights and the air curtains, for example. Here we're trying to shape the geometry as smooth as possible to guide the airflow smoothly past the wheels.
Zu führen und schön an den Rädern vorbeizuführen.
However, in other areas we're deliberately trying to provoke flow separation by using sharp edges, such as on the front skirt and front lip, for example.
Und an der Frontstaulippe unten.
Besides the airflow around the vehicle, another important aspect is the cooling flow through the vehicle. In other words, how to get enough fresh air to our engine. For this, we've put large enough air inlets in the vehicle. Here we have the kidney, and alongside more openings in order to provide the brakes with sufficient cooling air, and we have additional water coolers to the left and right. Here, every square centimetre of cooling air intake matters in order to get enough fresh air to the engine, but also to achieve this with as little aerodynamic drag as possible and minimize the effect on the aerodynamic lift.
Möglichst luftwiderstandsarm und mit wenig Auswirkungen auf den aerodynamischen Auftrieb umzusetzen.
One detail that we looked at closely on the clay vehicle is a typical BMW air curtain. This feature is used to guide the airflow around the wheelhouses and the wide tyres as cleanly as possible, in other words, with minimal aerodynamic drag. For this, we looked at various different designs in the wind tunnel to achieve the optimal air curtain geometry.
Als zusätzliches Aerodynamik-Feature haben wir auch
As an additional aerodynamic feature, we've put 3 flicks inside the air curtain to increase the front downforce.
auch eine Abtriebswirkung für das Fahrzeug zu erhalten.
Underbody aerodynamics is also developed at the clay model stage. Here, for example, we work with very simple front lip geometries in order to understand how specific geometries interact with the rest of the airflow around the vehicle. It is an important feature. Another point of focus was on the side of the vehicle. In collaboration with the designers, we found a shape for the sidewall and rocker panel that work aerodynamically to accommodate the wider track and larger rear wheels on the rear axle.
Anders als in der Fahrzeugfront.
In contrast to the front of the vehicle, at the rear it's important to control and manage airflow as it separates from the vehicle. For this, we introduced defined trailing edges at the back of the vehicle. The position of these edges is important, so we work in collaboration with the designers with millimeter accuracy to achieve optimal aerodynamics. The classical M rear spoiler is also a focus for us right from the start of the project. It's also a separation edge, but its main function is to create aerodynamic downforce, which stabilizes the rear axle. Using a so-called smoke lance, it's possible to visualize the airflow in the wind tunnel. The smoke trail gives a good qualitative impression of the airflow around the vehicle. For example, the wake behind the vehicle can be filled with smoke. Then it's possible to visualize where the flow separates from the vehicle. In the lower area, we now see the final geometry of the front lip. We see that it is cut back in the middle area and the height reduced. The negative pressure created by the separation helps suck air through the horizontal oil cooler, which exits under the car. So this part has functional requirements for engine cooling. In the outer area, the skirt is longer, creating a stronger negative pressure and thus increasing the downforce on the car's front axle. It also improves the airflow around the front wheel. Thus, we have fulfilled three functions with the front skirt. The cooling requirements of the horizontal oil cooler are met, a massive downforce is created on the front axle, and we're especially proud of the fact that the drag of the vehicles is also improved.
Wir verbessern zusätzlich noch, worauf wir besonders stolz sind, zusätzlich verbessern wir auch den Luftwiderstand des Fahrzeugs.
Here we have the final design of the rear spoiler. Not only is it important to create downforce at the back of the car to stabilize the rear axle, but it is also essential to create the ideal aerodynamic balance between the front and rear of the vehicle for driving dynamics. We are now underneath the car to have a look at the underbody. Here there are also some aerodynamic features. Right at the front we have the front spoiler lip, which we've already talked about. We see here again the cutback area in the middle and behind it the horizontal oil cooler. Thanks to the negative pressure area behind the front skirt, more air flows through the horizontal radiator and thus along the underbody.
Den Unterboden entlang.
Further back we see one of our most important aerodynamic features, the so-called turning vanes. These divert the airflow further, which creates a region of negative pressure along the underbody.
Die Strömungsgeschwindigkeit am Unterboden, und zwar am gesamten.
This means that the downforce on the front and rear axle is reduced by about the same amount.
Und annähernd im gleichen Maße auch der Auftrieb an der Hinterachse sinkt.
Another aerodynamic feature we've introduced to the M3 and M4 is to raise the entire underbody towards the rear axle. That means that the complete underbody surface is lifted slightly. This becomes visible back here, because just before the wheelhouse it goes back to the original underbody level.
Auf die eigentliche Unterbodenfläche. Diese Anstellung des
This gently inclined underbody causes a slight diffuser effect, which increases aerodynamic downforce over the entire vehicle.
Vorderachse und an der Hinterachse.
Here we're driving on the Guadix circuit in southern Spain in midsummer. This is one of the racetracks that tells us if everything we pre-calculated in the development stage and then developed in the wind tunnel is compatible. If we manage it as well as we did with the new M3 and M4, we'll have a car on the racetrack with excellently matched cooling of all relevant components, great driving dynamics, and lots of driving fun, which of course we can also enjoy.